Here we have a problem that's asking us to simplify a square root, or tell us what number is equal to the square root of 64. And you see in the title that we're taking square roots of perfect squares. So we have a little bit of terminology that we need to understand. So the square root is simply asking for, here we have our radical, and underneath we have the radicand, or the number that we're trying to figure out what number, when multiplied by itself, is equal to this number under the radical. And when it's a perfect square, it means that the square root, or this number here, x, is going to be a natural number. So if we look at it, we can look at our natural numbers. We see 1 times 1, or 1 squared, is going to be equal to 1. If I took the square root of 1, it would give us 1, which is a perfect square. 2 squared then is 4, and we can go on up. If we don't remember our times tables, we can continue to go up. 3 squared would be 9, 4 squared, 16, 5 squared. These are all my perfect squares, 25. Here again, these on the right are the examples of perfect squares, because if I take the square root, it gives me a natural number. 4 times 4, for example, is 16. So if I'm taking the square root of 16, I want to find the number x times itself that equals 16, and that number is 4, or that whole number. So we'll continue to go up. We want to know what times itself equals 64. We could continue with this pattern if we don't remember our times tables. 6 squared is 36. You can always punch this into the calculator. 7 squared is 49. And then we finally come to our answer. 8 squared is 64. So the number, when multiplied by itself, that equals this number under the radicand is 8. 8 is our equivalent number.